Let's find together the inverse of a logarithmic function. We are going to work on the problem that you have on your screen. F of x, the function that we will start with, is the log with base 2 of x minus 2 plus 3. As we do for all functions, we are going to set the function equals to 3, equals to y. So f of x is going to be equal to y. And this will be our first step. Next, in order to solve the function and find the inverse of this function, we want to exchange the x and the y's. So we'll write x equals to log with base 2 of y minus 2 plus 3. The next step is that we want to solve this function for y. So, step 1, we change the f of x to a y. Step 2 is interchanging the y and the x. Step 3. Step 3 is that we want to isolate the y, but the y, it is in the argument of the logarithm. So the first step is to move the number 3, that is a constant, to the left side of the equation. So now we have x minus 3 equals to log with base 2 of y minus 2. Okay, why do we do that? Remember, our goal after step 3 is to isolate the y. In order to do that, we need to perform all the operations in the order of PEMDAS. So the first thing that we need to do is get rid of the 3 from the right side of the equation in order to leave the logarithm by itself. So we isolate the y. That's our purpose. Now we have on the one side of the equation we have just the log, and on the other side of the equation we have x minus 3. The next step is that we want to get rid of the log. In order to get rid of the log, what we have to do is to raise both sides of the equation with a base of 2. So we rewrite now the equation as an exponential equation. We choose 2 because 2 is the base of the logarithm. And since the two quantities, left and right of the equality symbol right here, are equal, if we use those two to be the exponents of the same base, number 2, then the equality holds. So the two sides of the equal sign will be equal for both a, that is the equation that we started, and b, that is the equation that we created. So again, what do? We choose the number 2 because 2 is the base, and then what we do is that instead of having x minus 3 equal to log with base 2 of y minus 2, that these two things are equal, these two quantities are equal, we use them for our powers, so we use them as exponents to our powers with the same base too. So now in the equation B, we can see that basically what we have is that these two quantities are equal. So the next step is to use one of the logarithmic properties in order to simplify the right side of the equation. Now what do I have here? I have 2 to the log of 2. So in this fourth step, what I'm going to use is the property of logarithms that tells me that whenever I have a raised to a log with base a of any number, let's say k, then this is nothing else than the number k. So instead of having the entire power right here on the right side, I can simplify the 2 with the logarithm, and this is going to be equal to y minus 2, that is just my exponent. So basically I bring the exponent y minus 2 down right here, using the property that says that a to the log with base a of k is equal to k. Now things are easier because y is not anymore inside the logarithm and it is not in the exponent. So the next step is again to isolate the y. This is always my purpose. This is always my goal. So in order to do that, what I need to do is to move the negative 2 to the right, to the left side of the equation by adding to both sides the number 2. So what I do here is I'm going to add 2 to both sides of the equation. Two minus 2 is going to be equal to 0. So we can see that y now is by itself on the right side of the equation, while on the left side of the equation I have 2 to the x minus 3 plus 2. So this is the y. This is equal to 2 to the x minus 3 plus 2. And the fifth step, of course, when I solve for an inverse, is to change the y with f to the negative 1 of x. That is the inverse of the initial function. So now what I have is f to the negative 1 of x, the inverse of the function, is equal to nothing else than 2 to the x minus 3 plus 2.